How is everyone? Good? Sleepy? Tired? Did you guys get any sleep yesterday? Nice. Good. Good. That's good. Everyone enjoying Codebits so far? Right, I think I'm going to start. So good morning, everyone. My name is Jose Airosa. I'm a Ruby developer, and today I'm going to talk to you about Ruby and game development. And basically, what I want to tell you and to explain to you is my experience as I'm not a game developer at all, and you'll see in a second that I do something completely opposite to game development. But I do love games. I do really love games. Before I start, are there any Ruby developers here? Okay. Doesn't need to be Ruby developer. Have you guys ever seen Ruby at all? Just the language, anything? Okay, cool. Any game developers? Nice. Okay, good. All right. So what to expect from this talk, and I always like to give you a small intro to what I'm going to talk about so that you know what to expect. So I'm going to start with why games. Well, why did I decide to do game development? Why did I choose Ruby for my tool to develop games? I'm going to give you a quick intro to game development. It's going to be very brief, just so that you are aware of the things that I will be doing, and you'll be able to picture in your mind what I am doing. Then we're actually going to make a game. It's going to be a very simple game. You'll see this probably the simplest game you can develop, but taking into account that this is a talk, I cannot make a very complex game. And then I'm going to show you some extra stuff. And at the end, we'll have some Q&A, the normal thing. So again, my name is Jose Airosa, and I, at the moment, live in the beautiful, sunny, warm London. Yeah, it's more or less like that all the time, more or less. And I work for a company called Simply Business. So we are, at the moment, the largest online business insurance broker in the UK. So as you can imagine, it has nothing to do with games. We are insuring loads of companies, and we have, one of the things that I wanted to mention is that we have one of the biggest Ruby on Rails teams in the country. So that's quite an achievement, right? And if you want to know more about the company, do come and speak with me afterwards. I've got 3 more colleagues that came with me, so you can just find them and speak with them. There you go, they're there. So why games? Why games? What's the point? So it's kind of a cliche, but it's like everyone. I started to play games since I was like maybe 6 or 7, playing Prince of Persia, and then it escalated. I started to play more games and more complex games, and then started actually trying to be a bit more hardcore gamers. And I've always loved programming as well, right? So until maybe 1 year ago, I've never even attempted to develop a game. So I said, well, why not? So these are some of the games that I've played. You're probably going to recognize loads of them. So I didn't develop any of those, of course. That's massive. I wouldn't do that. But the next thing I want to talk to you about is why Ruby. So why did I choose Ruby? So I've started developing with Ruby maybe 3 years ago, more or less, when I went to the UK. And one of the main reasons is Ruby is C under the hood. And it's quite easy to integrate with OpenGL. And OpenGL is basically the core of a lot of game development, right? And the ability that you have as well to use an extremely easy language. So Ruby was built for humans, not machines. That's what Matt said. So Matt is the guy that created Ruby. And it is true. I'm going to show you the code in a bit, and you're going to be able to literally read the code like if you were speaking with someone. The other thing is that it's extremely flexible. So they've made ports of the Ruby language to loads of other languages, like Java, Objective-C, So, that's a two-way blade. That might tell you that Ruby is actually, so when people start using Ruby, they actually want to have something else. But at the same time, just shows you how flexible the language can be in order for you to be able to develop in one language, and actually underneath, you're just doing something completely different. Some examples are JRuby, for example. It's the full Java implementation, and you just write Ruby, and it works. And it's fun. It's actually fun to develop Ruby. I've developed Scala. I didn't have fun. I developed Java. Oh, God, I didn't have fun at all, really. Nothing. Zero. So let's get a bit into game development. And as I said, it's going to be very brief, but it's going to be enough for you to have an idea of how games work. So this is a basic concept, right? If you probably remember from high school, you have the x-axis, you have the y-axis, right? In game, or at least in here, it's actually the opposite. So the game starts to draw from the top to bottom and left to right, right? So this is something you need to be aware, because when you're going to be positioning your objects in your window, you need to be aware what y-axis and x-axis to give it to it. The other thing is the loop. So this is the core of it, right? So when you start your game, there's a setup that happens. So either initializing objects or fonts, images, whatever, variables, and we'll get to that in a bit. But then you get to the loop. So the loop is, as you can see there, is just that constant loop. So you go from update, and update is where you change the state of your game. So if you want to change positions, if there's physics being applied to it, that's where it's going to happen. Then we move on to the draw, and the draw, there's no state change at all. So it's literally just taking what the updated and draw it onto your window. And then you got the wait. In this case, we're not going to actually use it, but that is influenced in terms of time. And there's the cleanup as well, which we're not going to go into, but that's a generic loop. So this is a bit of code. This is Ruby. Don't mind so much about the actual code there. So at the moment, I want to focus on the setup, on the draw, and update. So initialize, as you can see, just like I said before, we're going to create a new ball. You're going to have some variables that we're going to initialize it as 0. So that's the game just started at 0. Then we're going to load some fonts, videos, sounds. And this is actually where you can probably have a load save game functionality, for example. So as I said, assign vars and load the game, for example. Then we move on to update. So update, in this case, is where we change the state. So by state, you change the position. So in this case, for example, we're going to tell a ball to move, right? Doesn't matter. The responsibility of moving is from the ball. We just tell it move, and she will update itself with whatever physics are applied to it or functions you're going to apply to it. Then there's the human interaction, so player input. So if you press WASD, up, down, escape, whatever, space, then that's where we're going to take that into the equation and do something. So in this case, for example, if you press your keyboard W, then we're going to move a left pedal up. And you're probably now seeing what game we're going to be doing, but it's going to be clear in a second. There's also the concept of time. So you can say, all right, so imagine Super Mario. You're playing, and there's one of those plants that comes up and fires a ball. So that ball fires every 5 seconds. This is where you equate, say, OK, the last ball was 5 seconds ago, more or less. OK, needs another ball to come out. And do mind that this loop happens. So you can change how often the loop is called, but it's literally every 10 milliseconds. Depends on the engine you're running it. So when you see slowdowns, it's probably the computer not being able to cope with the updates. And randomness, it's, for example, every time the game starts, you don't want the game to look the same every single time. Or if you're going to a door and you need to update something, you need to change something. There's some randomness going into. Then lastly, we're going to have the draw. And as I said, the draw doesn't change the state at all. So for example, in this case, we're going to draw a ball. So you've got the ball object, and we're going to say, draw yourself onto self. So self, I'm going to get to it in a second, but self basically is the main window. So we tell it where we want you to be drawn. And then there's some font there that you can also draw. You give it some string, you give it a position, the 0, wow. The 0 basically is the z-axis, so you can move it forward or back in terms of your depth. So this is a very over-the-top introduction. And we're going to move a bit more now into Gosu. So Gosu is the library that if you want to develop the 2D game, you're probably going to use Gosu. Gosu uses OpenGL, so it's wrapped around OpenGL. Has a really good community. As a quick note, so I was at RubyConf in Miami last year. And this is where I saw another guy having a talk about this. And that's where my inspiration comes from. And the community around Gosu is actually really good. There's loads of forums, so if you need help, they will help you. There's loads of documentation. It also lets you go down to OpenGL, right? So this is where we probably, at the end of this conversation, or this talk, we're going to probably see if does it actually make sense? Because once you go to OpenGL, why are you using Ruby? Is actually worth, because you're actually going way too deep down. Does it make sense to keep using Ruby? But we'll get there in a second. So this is how your, it's not updating anymore. Give me 1 second. Oh, there we go. All right. So this is a bare bone window. So if you run this, you're going to see a black window. It's going to be just a black window with a caption on the top of the window saying hello Codebits. It's going to be rendered with a 640 by 480. And the false just means we don't want it to go full screen. So it's just a window. That's it. Then moving on to the draw. So this is, I'm not going to be focusing on the draw itself. I'm going to be focusing on Gosu draw. So what can you do with the draw? So in this case, for example, draw a polygon, right? So just draw a simple square. So you give it 4 points, you give it a color, and Gosu will go to OpenGL, tell OpenGL to draw a polygon, and then when you draw it, it's going to show as a small square. Then going to images. So the images, and I've added a small comment just because I'm just speaking about images, not where they fit. I just added the comment say, so that's where you're going to probably initialize. So in the setup, if you remember, when you initialize, that's where you're going to say, that's my image. And then at the draw section, you draw it, we give an X and Y position. Then fonts is the same concept. So again, you initialize a font. The window is, you can have more than one window. In this case, I'm just going to use the normal window, the default window. But you can give it a name. So the name is like Verdana, Comic Sans, something like that. And the size of it, it's the normal size in pixels. Then you draw, and you tell it, draw me something. So in this case, like we said, you probably lost the game, so it's a game over. Then there's a couple of helpers, and these are really good. So for example, this is for input. So whenever you press a button, Gosu is consistently waiting for your input. When something happens, then you do something. So if you have button down, WASD, do something. It can also have access to the mouse position. So if you want to change the mouse with something, if you want to interact with the mouse, you can do it like that. Then also you have sound. So you just give it a file name. And that's as well at the setup. And whenever you want to play it, for example, you died, or you just threw a fireball at something and you want to have a what, something like that, then you just press play. When you have some sort of collision, you press play and your sound comes out of your speakers. And it just works out of the box. You just say play and it plays the sound. And of course, you know, if you're going to get into games, there's going to be loads of math around it. There's a lot of frameworks that will do a lot of work for you, namely like physics engines. And I'm going to talk about one of the physics engines. Even though the game that I'm going to develop doesn't have any physics applied to it, one game that I'm going to show at the end will have some physics applied to it. So for example, in this case, based on a given angle and the speed, tell me the X position. So this is what you're going to use whenever you want to have movement. This is what you're probably going to have, and you need to use the two at the same time, and this is going to create movement. This also you can have, for example, the distance between 2 points. In this example, I'm only going to use the offsets. So there's another gem. For the ones that are not acquainted to Ruby, gems are libraries. So whenever you want to have a library, just call it a gem. You install it, you require it, and it just works. So there's Hasu. And Hasu is built by Mike Farley. Mike Farley was the guy at RubyConf that did a talk. And he extended it slightly. And it's really useful. So for example, hot code loading, it means that in normal situations with GoSum, if you change your file, you need to close the window, start the game again for the setup to run again to get access to the change that you made to the file. With hot code loading, you literally change the file, and because Hasu is consistently trying to read the file, it will just pick up the changes, load them onto memory, and show you the change. There's also exception catching. So if there's an exception, Hasu will halt everything, give you access to the terminal. You can debug your code and fix it without even having to close the game. And then you got the reset. The reset is a really useful R button press, which basically just resets all the game. Basically just calls setup again without having to close the window and open it again. All right, so getting started. So let's actually try and do a game. I'm gonna try and do this as best as possible. Do let me know if you are confused. If you have questions, let me know. I'm trying to try and do this as simple as possible. So I've got here the game. So this is the start of it. I've added a couple of things. You're not going to see what I've added. But if I try and run the game, so if I just do Ruby game.rb, this just loads the game. And this is just a window with nothing else, just a mini image on the background, and that's it. Right. So let's start to add something. So what we want to actually start by doing is, and by the way, I forgot to mention, we're going to make Pong. You probably guessed it by now. We're going to make a Pong game. So let's start by actually creating a ball, right? So the first thing you need is a ball, and we're going to put it in the middle of the screen. So let's start by just go here. All right, there we go. So let's call a ball. So let's do class ball, and then let's give it a size. So let's say that's going to be 16 pixels, and then we're going to, so for the ones that are not Ruby, this basically just gives you getters and setters. So let's say we want a getter for X, a getter for Y, a getter for an angle, and a getter for the speed. All right. So then we start the ball object. So whenever you call new, this is what the function is going to be called. And we're going to say that we want to start our X, and we want our ball to be in the middle of the screen. So we're going to go and call our main window, and we're going to say, OK, give me your Y, and divide it by 2. So that's going to give you X in the middle. And so if you do the same thing for the Y, and we're going to say game, height, divided by 2, and that's it. For now, that's it. Then the other thing is I'm going to just put here a quick helper for you to be able to understand better. So just 1 second to get the ball. Because this X1, X2, sometimes it's a bit hard to understand. So I'm just going to copy-paste this here. Right. And this will hopefully help you. So you got that dot there. That's the X and the Y we just created. And in order to create our square, we need to move around and create the 4 points around the X. Right? So that's what we're going to do. So we're going to define our X1, right? And X1 is going to be our X minus size, and the size is 16 pixels, divided by 2. And what this is going to do is basically split in half, go back, and give me the x. Because the x only matters on this axis, doesn't really matter if it's up or down. The other thing is, as you can see, x4 is actually the same as x1, right? So it doesn't make sense to reset it. So I'm just going to create called an alias. So method alias, actually it's the other way, alias method, and we're going to say x4, x1. So whenever you call x4, it's going to call x1. Then we're going to do the same thing for the x2, and then x2 is going to be the same concept, but instead of minus, it's going to be plus, divided by 2, and we're going to do the same thing. It's going to be x3, it's going to be the same as x2, all right? And then we're going to go on to the y's. So if you do y1, it's going to be y minus size divided by 2. Hopefully I won't have many typos. Method, and it's going to do the same thing. So we're going to do y2, and it's going to be the same as y1. And you can see that actually, in terms of y's, the y1 is the same thing as the y2, so we don't need to reset it. And then finally, we've got our y4, and it's going to be y plus size divided by 2, and we're going to create an alias as well to y3. And so this seems to be a bit like tiring, but it's going to save you loads of time because every time you call these positions, they're going to take into account the x. So when you move it around, you're actually updating x. But because we got these helper functions, everything is going to compute into the correct position. So finally, every object that you create, you need to have a draw method. That's what we call. So we always call our objects to draw themselves, not the actual environment to draw something. So that's what we're going to do. We're just going to call draw, and we also need to say where we want to draw it. It's going to be self in this case, but we always need to pass it on. And in this case, we need to have a color. So I'm just going to have helper goes to, and then color, and then red. Great. And then we're going to say, okay, for my window, actually draw a quad, as we said before, draw a quad, and the quad is going to take all these positions that we just talked about above. So x1, y1, color. So you can have, every point can have a different colors. In this case, all of them are going to be the same. So x2, y2, color, x3, y3, color, and then x4, need a comma there, y4, color. Right. So that should be enough to get us started. Oh, sorry about that. All right, there we go. So basically what I did, I just draw the 4 corners, and now what I'm going to do is go back to my game, and we're going to say, all right, so we've got a new file that we need to load. So it's going to be asu load, and we're going to call our ball. And then we're going to go into our reset. So as I said before, I'm actually using hasu. And hasu as an extra method called reset. That's the one, when you press R, that's the one is going to be called. So what I'm going to do, I'm just going to say, okay, let's create a ball. And our ball is going to be ball.new. Right? And then finally, we're going to go to our draw method. And we're going to say, okay, so ball, just fix there. Ball, draw onto self. All right, so hopefully this is going to work. So let's go to here. There we go. So we've got a small red, that's not kind of ball, it's just a square, but for this case it's fine. So it's red, like we said, has the small size, so it's fine. So now we need to start to actually do something with the ball. Let's make it move. So the way we make it move is we go back to our ball. There. Let's go to the top. And when we initialize it, we're actually going to give it an angle. So what we want to do is every time we reset the ball or the game starts, we want it to go off in different directions because we don't want the game to be boring. We want it to be exciting. Every time you start it, it's going to go in a different direction. So let's try and do that. So if you do an angle, and then let's do... So there's a couple of math going on here. This is just creating angles for which the ball is going to start. So either like this, down, straight. So let's do like plus 30. And if you have questions, you can ask me. And then we're going to do the same thing. And what we're going to do is we're going to, based on the random between 0 and 1, we're going to see, does it go upwards or goes downwards? So this gives a bit more challenge to the game. So let's just go random. And if random is greater than 0.5, then it goes down. And then we're going to give it some speed, right? And in this case, our speed, I'm just going to say 8 for now, okay? So if you put it faster, it's going to be a lot more challenging, even impossible to do. So the other thing we need to do is actually have a method in our ball that we call it from our update, and we say, all right, ball, move. In this specific moment of time, move somewhere. And based on the angle and the speed, it's going to update its x-axis, or in y-axis. So we're going to create now, it's called the displacement of x and displacement of y. So let's call the displacement of x, and we're going to call the goes-to, and you're going to see a helper method that I talked about. So it's going to be the offset x, and the offset is always given by an angle and a speed, which we already have. So we're going to call angle and speed, and then stop, and then we're going to do the same thing for the y-axis. All right, there we go. So lastly, we need to create a method that when called move, do something, right? So let's do x equals our, it's actually going to be like this, the x, and our y like this. So what we're actually saying here is our x position and y position, which is the center of our square, is going to be, we're going to increment it, our displacement. So the displacement can be positive or negative. So we are just doing plus, and if it's negative, it's going to go on the other way. All right, so that's more or less it. And what we're going to do now, we're going to go back to our game, and in the updates, we're just going to say move. All right, go there. And we're going to say ball, move. Okay, so that's more or less it. So let's try and see if that's working. All right, that's the ball moving, okay? So let's try again and open it again. Different direction. Different direction. As you can see, something is wrong now, right? The ball is just going, whoa, see you later, bye, I'm going. So we need to have some sort of collision detection. So we need to look into the position of the ball, and if the position is outside of our window, we need to reset it and basically make it go the other direction. So it just goes up and down, or down and up. In the sides, it doesn't matter because that's where we're going to have the point. So if the ball goes after that way or here, then we have a point. So let's go back to the code, and let's go to our ball again. And what we're going to do is we're going to define bounce of edge. And you can see that I'm adding exclamation mark in these methods. Basically, I add this wherever it's going to change the state of my ball. It's because it's like, it can be a dangerous method. If you call it, that's going to change it. So that's just more for if someone is using, they're aware that this can happen. So what we're going to say is that if our y position, because that's what matters, we just want to know about the y, if our y position is less than 0, so remember 0 is up, then we're going to say our y is going to be 0, so we stop it from going further up, and then we change the angle. So we want it to go the opposite way. So what we're going to do, just do angle, goes to again, and then angle, And then this is going to be just so that you want to apply it at the center. So you don't want the angle to be applied somewhere else. Just in the center, it's fine. Doesn't really matter. And dx minus dy. So this is going to invert the displacement of y, which is what you want to do. And then that's it. That's for if it goes up. So if it goes down, it's more or less the same, but we need to play around with the window. Okay. So if our y is greater than our game height, then we're going to do, this is going to be the same, so we need to lock it. And then from locking it, we just invert y again. So that should be enough. And what we need to do now is, when we are doing our move, so if we go to our move, got our move there, we need to call this method when we're doing the move. So after updating our x and y position, are we going to say, okay, do we need to bounce? If we need to bounce, then we need to change something else. So let's do that. And let's try it to see if that's working. All right. Thanks, ball. Thanks. Got them random. All right. There we go. We just close this. Let's try it again. There we go. Just bounces slightly down there. All right. So now we're missing something else, which is the pedals. So we need to have the game now. We're going to have two pedals on the sides. They go up and down based on your input, and we need to afterwards bounce them on that pedal. So what I'm going to do is, because I already showed you how it works in order to speed this up a bit, I'm going to just go and get our ball pedal here. This. And like this. All right, so there's a lot of code there, which I'm going to go through it. Sorry, this one. All right, so we've set up a pedal. We give it a width and a height, so you can see it's not squared anymore. It's just like a small pipe. In the case of the pedals, it doesn't really matter the x-axis, because the x is always going to be the same. The only thing that changes is the y, up and down, up and down. Then we're going to initialize it, and you're going to give it a side. So we use the same object to draw the left and the right pedal, and we just call it side. So whenever you call it, we're going to do slightly different calculations if it's the left one or the right one. Then we're going to set it as always at the center of the screen. So when it starts the game, they're always going to be at the same place. And then when a game starts, you can just move them around. Then we're going to have here a move. And what I'm going to do here is just comment this out for now. And you'll see the difference in a second. So if you press up, then the y-axis is going to move up. If you press down, then it's going to go down. Then we have all those helper methods, and this is why I didn't want to write everything again. Doesn't make sense. This is the same helper methods that we did for the ball, but they are applied to the pedal. So what we do is x1, and I'm going to show you down here. So this is our pedal, right? So it's more or less the same concept. Instead of being a square, it's just a pipe, a small pipe. And we got x1 at y1, x2 y2, x4 y4, and x3 y3. The order doesn't matter. You can draw it as you want, as long as they are sequential and if they make a closed polygon. So we have our x1, and the x1 is going to be the one that based on the side, so if you do left, it's going to be 0 because it's going to be on this side. If you do right, it's going to be on the far right side. And what we do is do game width minus the width, because the x1 is this one here. So if we're going to put it here, then we're going to want to go all the way down here and then just go a bit back, and that's where our x1 is going to be. So the same thing applies to x2. We still have our alias methods because we don't want to be calling everything again. And then we have our draw, which is literally exactly the same because it's still a quad. It's still 4 dots. They are just in different positions, which makes it a bit different. So now let's go back to our game and add those pedals. So we do the same thing, hasu.load. Let me do it here, it's easier. Lib pedal.rb, save, it's all the same. And what we're going to do is we're going to initialize them. So we're going to do left pedal equals a pedal new, and we're going to call left. And then we're going to say right pedal right. Right? So that's more or less it. And then we cannot forget to draw them. So if we call this without drawing them, you're not going to see anything. So we do the same thing, left pedal, going to do right pedal. And it's always the same concept. We tell them, you need to draw yourself onto, let me know if because I'm looking at this screen, if you don't see anything, just let me know, scream or something, and I'll just make sure we're looking at the right thing. So here, let me just move slightly down. So there, we've had left pedal, right pedal, and draw yourself onto the main window. So let's try and see if this is working. All right, so let's go to our window here. All right, so we've got two pedals. They don't work, so if I press anything, they're just there. So the game is kind of boring right now. So let's give them the movement. So you remember that we have our up and down. So in our pedal, we've defined already up and down. So the only thing we need to do, actually quite simple, just need to go to the updates, and we need to say, so if button down, and it's going to be a gosu, and it's going to keyboard Y, then we're going to do left pedal up, and we're going to do the same thing for, so I'm using W to go up, S to go down on the left pedal, and I'm going to use the up arrow and down arrow to go up and down on the right pedal. So if we do up, down, and we're going to change here for right, right. I think that's right. Oh, just need to change this to down, down. Otherwise, all is going to go up. Okay, so let's give it a try. So there you go, up, down. I'm pressing W and S, and now I'm pressing up and down. So there we go. So at the moment, there's no collision detection between the pedals. So if the ball will just go through it. So that's kind of unwanted. There's another problem. Look at that. There we go. Bye. See ya. So we need to make sure we lock it once it goes there. We don't want it to go above or over the window. So that's quite easy to fix. And you saw it. I was fixing that just a while ago. So if we go back, let me just close the game. So if you go back to our pedal, and let's delete this one, uncomment this one, uncomment this one, and this one. So what I'm doing here is I'm using Y1 and Y4. The reason why I'm using these ones and not the Y is because the Y is going to be at the middle of the pedal, which means that it's going to be halfway in when it's going to stop it. So we're going to do, if we're going up, and if we're actually over the window, then lock it to 0, or basically don't update it if it's over 0, and don't update it if it's below our window height. So that should hopefully lock it. So done. I'm pressing it, up, still pressing it, down, still pressing it. So that's the basics. Right. So now let's move on to actually doing the intersection between the pedals and the ball. So we want the pedal. So, and there's a small thing we're going to do, which is if the ball hits the center of the pedal, we want it to go straight back. But if it hits the top, we want it to go a bit more up. And if it's down, a bit more down. And if it's more or less in the middle, like this. So basically, it's like this. And this basically gives the players some strategy if they want to try and trick the other player. So we're going to do that by introducing a small calculation in a ratio. And I'm going to show you that. So the first thing we're going to do, let's go back to the code. Let's go to the game. What I'm going to do here is just do, so what I want to change here is that if the ball intersects our pedal, so I don't have this method at the moment, but we're going to have it in a second. So if, this is the main concept behind it. If the ball intersects, and this, as you can see now, the way I'm reading it, I'm just literally reading the code, and you can understand exactly what I'm saying. So if the ball intersects, question mark, yes or no. And this is one of the things I love about Ruby. Left pedal. Then we're going to do something. And if the same thing happens with the right pedal, then we're going to do something else. So right pedal, there we go. So what we're going to do is then ball is going to bounce off pedal. And you can see again that I am doing the question mark pedal. And then the same thing for this one. Right pedal, right? So let's implement those functions there at the ball. So for time's sake, I'm just going to literally copy-paste the methods, because otherwise it's going to take a while. So if we go to our pedal, and let me just copy and paste those methods. There we go. So in our ball. So we need the intersects and we need the off pedal. So I'm just going to copy it. You're going to see them in a second in the screen. So if I go to the ball, right, there we go. So we've got intersects here. So this is a generic intersection or collision method. So it's y1, y2s, and just seeing if they are going past them. And then what we're going to do is bounce off pedal. So this is the other method we did. And based on the side, we need to bounce it slightly differently. We apply it an angle. And this is where the ratio comes to. So the ratio is basically just we detect how far away you are from the source. And I call the source 0. And based on that, we have a higher angle or a lower angle. So like this equals like this, like this equals like this, like this. And the other thing we're going to also do is increase the speed, right? So this is to have a bit of challenge. So if every time it hits the pedal, it gets slightly faster, faster, up to a point where one of the players are not going to be able to catch it. So let's try that and see if that's working. There we go. Oh, there we go. Oh, that's good. Sorry? Oh, okay. Sorry, you would say? Oh, okay. Oh, sorry. Thanks. All right. So let's move on to the last part, which is the score. So we need to update score based on if it goes out of the bounds of the left and right. So we're going to do that in the game. We're going to start by, in our reset, we're going to set some left score 0 and right score 0. And then we're going to do, in our updates, we're going to say if our ball is off left, then we're going to do right. So when it goes left, the right player wins. So right score is going to be 1. And the ball, we're going to create a new ball, basically. So just going to say ball.new. And this is going to reset the ball to the center again. And then we're going to do the same thing. Oh, sorry. Thank you. So we're going to do this, like this, ball left, ball right. And we're going to do here left score +1 and ball again. And then we have as well as, you need to create a font here. So we're going to do font equals goes to font new. And as I said before, we need to tell it where it's going to be drawn. We're going to call a Verdana, for example, and we're going to give it a size. And at the end, when we draw everything, we're going to have the font to draw itself with the left score. and then we're going to give it a position, and then we're going to do the same thing for the right one. Ah, okay. Obrigado. There we go. And then what we're going to do here is do wide minus 50, because that's where we want to position it, and that should be it. So we're really close to the end. Oh, God. So we need to implement those two methods. So we're going to go to the ball. And those are actually quite simple methods. So what we need to do is go down here. This is in our ball again. So I'm going to go down here. And we're going to define off left. Then we're going to do x1 rather than 0. So if it goes off, then we're going to do off left. So it returns true. And then we're going to do off right. And then it's going to be x2. So x2, remember the x2 is on the right side. So that's we're going to check it first. It's going to be greater than game wife. Right? So let's go and try it again. There we go. 1, 2, 1. Right, and that's more or less it. So you can play 2 players. It's a very simple game. And yeah, that's more or less it. That's for the game itself. You could add more stuff. You can have, for example, if you press escape, just quits the game and stuff like that. All right, so back on to just quickly go over. So step 1, we're going to build Pong. We set up the environment. We initialize the variables. Step 2, we create the ball. We define the ball attributes. We make the ball move. And we do some initial physics for our ball, so just collisions. Then we create our pedals. We define the pedal attributes, size and speed. Make them move by user input. Step 4, create interaction between the ball and the pedals. We have some point system. And then the final step is just make it more challenging. And this is where I had the speed going more and more and more every time it hits the pedals. And some bells and whistles was the escape. So just useful references. This is Chipmunk. Chipmunk is the physics engine. And Releasey enables you to package your game and deliver it for someone that is not running Ruby. There's loads of information at Chipmunk about collisions, and the way they do it is really good. I'm running a bit out of time, but if you want to know more about Chipmunk, just come and find me. And what else can we do? We can probably do this, which is the annoying yellow bird that's not able to fly properly, and I want to throw my phone at the wall game. And I tried to create the same game. And see if it's going to work well here. So this is Flappy Wings working entirely in Ruby. All Ruby with Chipmunk physics. Yeah, and it runs really well, all full FPSs. There's some artifacts coming out of the numbers, and that's basically from the outline. There's a problem with Ruby and the way it communicates with OpenGL, so you get those artifacts. I'm trying to get it fixed with the creator of the gem that enables you to do the outline. Other things you can do is Minecraft. There's actually a guy that did Minecraft in Ruby. It's pretty awesome. I saw it at RubyConf, and it works. It really works. It's really good. And it's like 800 lines of code. So conclusions. In my opinion, I think it's plausible. You can develop games with Ruby. 2D games, 3D games, I think it's too complex. You probably want to use something else that is out there. But what I think that Ruby is amazing is for kids. I think, so just imagine the way that you read Ruby is really easy. So you can actually get kids into development with games. You know, what's more motivating for a kid than a game? So getting them to develop their own games is actually really quite good. And when I was at RubyConf as well, there was a talk about something called Kids Ruby. So in America, they're actually investing a lot in Ruby and in kids development, which is really, really good. There was, I don't know if it's here, someone talked to me about kids development a couple of months ago, but I don't know if they're here at the audience. So yeah, do you guys have any questions? Anything that you...
Hi.
Hey.
Do you have any mechanism to destroy your ball? Because I know that garbage collector removes the ball object that goes away, but the physics goes on that object, right?
Yeah.
There are any mechanism to
So
avoid that?
it's a good question. So the way it works is you let Ruby do it. So Ruby is really good with garbage collection, and you don't mess around with it too much because when you create a new instance of that object, the old reference is not there anymore, which means next time the Ruby is going to do the garbage collection, it's just going to dispose of it.
But it's fine when you have one ball, but it isn't absolutely fine when you have 10,000 balls.
Right.
Yeah.
Well, in that case, there's a couple of libraries that enable you to tap into garbage collection and to destroy those objects. But then again, it comes again to the same conclusion. Is Ruby the right language to develop games, right? Yeah. It was never intended to write games. This is an experiment. In my opinion, if you're going to do 2D games with sprites, like simple animations, like Flappy Wings is probably, I don't know, 400 lines of code. Took me a day and a half to write, and is using the chipmunk physics. The way it works, it really is really clever. It sets you up with a space, and you just add objects to that space, and then you say, actually, these two objects can have collisions, and when they collide, a hook comes up, and you can just tap into it and say, okay, do something else. So all that stuff that I did, if I had to use a chipmunk, that would probably be a lot easier. Yeah, there's loads of libraries. There's a lot of people investing into developing games with Ruby. If you guys are interested, definitely do it. It's fun. It's really fun. I had fun doing it. So yeah, it's a good
I have
question.
another question.
Sure.
I use Xenia C# framework to make games, and all the updates and draws are managed by the game manager, and I don't have to call it explicit on my game window. Right. There are any mechanism to do that in Gosu?
Well, you would probably have to write it yourself. I don't think there's any, at the moment, I don't think there's any way that you can do it with Gosu. So the Gosu is being updated consistently. Even like a couple of days they updated it. But I don't think that you need to specifically call every draw, so you draw this object, just draw it on them. You could probably wrap it around some automatic caller that just calls, you got all the objects in an array, and it just goes all through the array and just calls draw. You could probably do that, but it needs to be manual. There's no way to do it automatically.
Okay, thank you.
No worries. Any more questions? All right. Thank you very much for watching, guys.